Thank you for coming to my talk. I mean, it means a lot to me, obviously. It's my second talk at NDC, and I'm still very nervous as the first time that was last year. So just bear with me. Bear with me. Be easy with me. Anyway, my name is Cristian Prieto. That is my Twitter handler. I've been a software developer for around 17, 18 years old now. And this talk is designed for developers. And it's about something that I learned recently about like 1.5 years, 2 years ago, and changed my life drastically in the way that I do my daily work. And it's very sad because I felt sad with myself that I didn't discover that before. Because one day I just sit down with my partner. She's a data scientist, and she started like doing some crunching numbers. I was like, hey, that looks really nice. What is that? And I just discovered that I've been an idiot all the time, ignoring that. So it's about that. It's about people that have no idea about notebooks, specifically Jupyter notebooks and Python notebooks, that they discover that experience and return to work and start using in their daily work. Because while you check any data conference, any research conference in the last year, you will see always 1 or 2 talks about Jupyter notebooks. I had not seen developer conferences when they introduced that to developer, and that's the reason of this talk. To understand why this is so great, we have to understand that it's about workflow. It's about the steps that we do all over again every time that we are going to do the same thing. For example, how many of you are .NET or C++ developers in Windows? You see that dialog box so many times in your life. It doesn't matter what you're going to do. You are going to create a new project, you see this file new. You want to learn a new framework, you see this file new. You want to learn F#, you have to see this file new with the F# plugin to see new F# project. And it looks like something very small, but the problem is that I've been working as a technical lead for the last 5 years, and I have to do a lot of spikes, proof of concept, and develop algorithms for the things that we do. And I got tired of this. It's not only me. When Rattle, the IDE from JetBrains, was announced, one of the features that they said is that file new project was completely empty. Just think about that. Right now, every time that you do this create a new project, let's scaffold a new project with so many things that probably you will need or probably you won't. And once you create the project, the cycle is exactly the same. You write the code to experiment, you compile the code, you execute the code, sometimes you cry, and you repeat from the beginning. You just want to learn how to do a hello world, you just do a print hello world. How many of you learn programming doing print hello world? Exactly. And it happens all the time. That print sentence, or printf, is one of the saviors of debugging for all of us. Visual Studio is too fat for things like this. Eclipse is too fat. Don't let me start with NetBeans. So now we live in a new world, the world of code editors. We have things like Atom. We have things like VS Code. Just imagine, Microsoft is so conscious about this that they create a tool named VS Code because they said Visual Studio is too fat. And it's in the last 2 years, it's incredible, all the extensions and things and people using VS Code for their daily work. In my case, I have not opened a full IDE in a while. It's just editors. The next generation of that happened since a few years ago was the creation of what we call interactive repos or something like that. And the best example in .NET is Limpad. And it was one of those things that's so simple that you just like, wow, I don't need now to create a whole application with file new project to just test this NuGet package, to just check this algorithm works, to just experiment a little with LINQ and F#. And I love LINQPack for teaching. I love LINQPack for education. It's amazing. It's so much using education and for teaching new stuff that you can download templates that are designed to go step by step. So you learn a new thing, F#, LINQ, reactive extensions, things like that. The characteristic of what it makes it so nice is the fact that you don't have to deal with things like MS Build. You just write code at the top, and you see the execution and the output at the bottom. So much like that you can create your own viewers. You can extend LINQPack, and you can show plots, you can show graphs, you can show so many other things that are not just tables. So it was extensible, and many people loved LINQPack. I love LINQPack. But there was another problem, and it's live documentation or documentation. Let's say that in your workflow or once you are learning things, you just need to take notes. This is important because you are learning something, you are discovering something, and you have to show this to your boss. If you are lucky, you probably have to deal with things like you already discovered Markdown, and you use Markdown to take those notes very easily and things like that. Sadly, in research or in most office environments, Markdown is a luxury, and you have to deal with things like Microsoft Word that are even like really bad to display code. So most of the time, what you have to do to create that report for your boss is write in Microsoft Word or even in Markdown if you are lucky, see the snippets of code that you have, copy the snippets of code, paste in Markdown, and it will be rendered as code, paste in Microsoft Word, and pray to God that it will show the highlighting. And it's an awful cycle because there is this disconnection between what you are doing in your code and what you're trying to show. In fact, the other problem is how you are going to track those changes, how you are going to show those things with your colleagues, to your boss, how you are going to request those revisions. Most of the time, what you do is that you attach that document in your email, or if you are lucky, you are use something like Dropbox, or even if you are super lucky, you use GitHub and push your Markdown document and wait people to get your feedback. So far, we have resolved all of those things, but there is something that is not as easy to solve, the code execution. Remember that so far, what we have now in the directory is a bunch of scripts or files or a project, a bunch of Markdown documents that say things that you are doing or trying to explain. Copy-paste of that code in that document. And you are asking to somebody on the other side, trust me, it works. The source code is over there. If you want, you can compile and check. But it's not that transparent. You lost that execution. You lost the evaluation of your code at the same time, at the run. This is not a new problem. This is a problem that somebody started solving in 2001. His name is Fernando Perez. He's a Colombian who was studying his, I think, postdoc in Berkeley, I think. And, you know, when you are studying your postdoc, you have too much time and you want to procrastinate as much as possible. And one of the things that he did was like, you know what? I don't like the Python interpreter. I think it could be much, much better. And he decided to just don't study for his dissertation in that moment, and instead create a set of scripts in 2001 that, as far as I remember, was something like 273 lines of code. They are in GitHub as well, like in his account, so you can check. That you run at the beginning of your Python interpreter, and it just gives you a lot of nice things, like highlight coloring, like, you know, color highlighting in your code. Autocomplete, tap autocomplete. The evaluation, you can see the input and the output together. You can change that input and output together. And that thing changed everything. It was just a big hack. The story says that he just continued hacking that. He eventually finished his postdoc. But little by little, he improved it and becomes what is known as IPython, or interactive Python, that now it has more than 78,000 lines of code from those 200 something that was at the beginning. What he was looking for was a better way to execute code and give that back. IPython gave you many things, like introspection, tag completion, have a rich history of what happened, better debugging. You can see like the things that are happening where debugging, but still just an interactive shell. It was not what he wanted. But that was the right way, because he designed IronPython, or many people with him designed interactive Python, in such a way that was pluggable. And other people could connect to the sessions that they were having. In fact, it's as well, one of the advantages that is that it's completely separate from the shell is that you can just do parallel activities. You can just have IPython workers in other machines, and from the shell, just put parallel computing for them to process your results. The guys from Microsoft that were developing the Visual Studio tools for Python have a chat with him. And he said, like, oh, yeah, it's very simple. You know what? There's this protocol to implement. And they were like, oh, okay, bye. And just 2 weeks later, he just announced an extension for Visual Studio tools for Python that use IPython, because it was so easy to implement. Pérez says that they didn't even need to ask them how to do it. They just did it. And it was everything nice. Now we have IDEs with that flexibility and things like that. This was before Roslyn, by the way. But he says that from the beginning, what he wanted to do is emulate mathematical notebooks. This is something that exists since 1998. And the idea is that because they are mathematicians, they are writing equations that they need to evaluate at runtime. He says that he fell in love with this idea while he was doing his postgrad, because he has to use a lot of Octave and Mathematica at the same time. And he wanted to bring that to Python. Little by little, it was many years. And around 2008, 2009, with the help of a few other companies and people, they could embed that IronPython and that IPython, interactive Python, in a Qt console. So they have things like this, with the capacity to show you graphs, charts, and more information. The same as Python. It's like, let's call it an IPython with steroids. Somebody has a brilliant idea. What if we put IPython in a web page? I mean, it's already in Qt. It's completely separated. For around like 2012, 2013, they did it. And they call it IPython notebooks, or IPython notebooks. And it looks like this. Notice many things in this documentation. This is a live documentation. Notice that we have full Markdown support for equation, and that is just Markdown rendered in different ways. It supports LaTeX as well. And the most important thing, you can write code, and the code is executed in your page. It's interactive, and it keeps the result. You just can't send this to somebody else, and they are going to execute that. They can modify it and see the results. This is so valuable for research, because it's basically, you can experiment with new things, grab all the data from your data sources, see in a table, study and manipulate that information, see immediately what is the result, and everything is in the same document. Just imagine that you have the ability in Word to just write something and at the same time see how things have changed on the fly. And it's cross-platform. In 2012, IPython just split and became what is called Jupyter Notebooks. This is what we are going to talk about today, because IPython is just the Python kernel for Jupyter Notebooks. Jupyter Notebook is the new thing. You can execute code, see the results as images, sound, it's extensible. You can read the format, you can export whatever your whole notebook, so you can create a filter in Word, for example, to get that information. You can reuse notebooks and link notebooks between them. So in that way, your notebooks will become modules. And more important is the latest version, that is Jupyter Hub, supports multiple users. So you can collaborate between people, and they can see what you are showing to them, and they can edit at the same time. We will just see that later. It supports LaTeX. And one of the things that I said, that is the part that excites me, is that you see the results as live documentation. It's things that you have with you, and you are seeing what is happening. This is a very valuable tool for things like learning languages, learning algorithms, learning frameworks, showing experiments of your code to your colleagues without having to deal with file new. It's time for demo. Quick demo, the first demo today. Let's see if I can make the font a little bigger for you. Yeah. Okay, let's start from the scratch. I have another demo with a more complex notebook, but let's say that you are just starting and want to install your Python notebooks. First, we create a new virtual environment. This is something very common between Python users, using virtual environments. It's just a way to isolate your development from everything else. Now let's install some stuff with pip. It's just that simple. It's the equivalent to NuGet in Python. You just pip install IPython all, and it will install all the requirements, dependencies for IPython. It's a little big. Here it's like kind of fast because I already did that this morning, so it's cached. Now that we have here and we have the environment, we can start the notebook with just IPython notebook. And it will give you a message here. I will explain why that message happens regarding a token or something like that. Is because security. Because remember that now it's a multi-platform, a multi-user system. And let's go to that URL. Let's put the font a little bigger. And this is the environment. That was all. It was very fast to install. It will install Python and it will install the default kernel. We'll talk a little more about kernels later. You have this interface where you can see your file system, because one of the big differences that we see in IPython and Jupyter is that you don't need a database. He uses the file system. It's just simple JSON files that contain your information. There is no database to deal with, no weird installations, nothing. As you see, I did that like super fast. If you are using Windows, in Windows, if you use Python alone, just use pip and install. But I recommend using Anaconda. That is something very common between data scientists. I personally don't like Anaconda because I feel that it has too many things that I don't use. But if you use Anaconda, Python Notebooks is installed by default with Anaconda. So let's create our first notebook. Notice that I have something there saying Notebook Python 2. This is because we are going to see later you can handle many, or Jupyter supports many different languages, and they are pluggable. You can just have Bash, or you can use F# or Camel, things like that. By default, it's installed only with Python 2. If you install Python notebooks in Python 3, obviously the kernel that is going to appear there is Python 3. Let's create a new notebook in Python 3. And this is what you see all the time. The title is where you change the title. Let's put here, hello, NDC. Yep. And now you have what is called cells. You have cells types. It's where you type things. If you type Markdown, that is going to be the first one, it evaluates Markdown. So you have titles. Let's put something nicer. And it will evaluate into Markdown, obviously. You can just put something else. And it works nice. Notice that you can insert cells at the top or at the bottom. That is important because it's the order of evaluation. You are evaluating those cells. You can use the results for one cell to do a calculation in the bottom by another cell. It's like basically a nice Excel. Another thing that you can do is that you can embed, important. The Markdown flavor that you use is GitHub flavor and Markdown. And that's important for me. I don't work in GitHub, but it's important for me because most of the technical documentation that you write depends on code highlighting and certain things that the flavor Markdown by GitHub or the Markdown that GitHub uses is designed for those things. So that's the flavor supported by Jupyter Notebooks. That gives us as well abilities to do other things. Like, for example, add an equation. The equation supporter of the equation language for the equation is LaTeX. So that's a LaTeX equation. And it will render nicely. You can edit what is already done. You just double click and you don't like the name of this K, I don't know, let's put it I don't know even what is that equation about. I mean, I just copy paste from somebody else. I'm no mathematician. The same with all the other cells. You can modify their content. Another thing is that you can embed the questions together with your Markdown, all together. What it uses is MathJax. And now it even looks like you are an academic or something like that. Of course, you were not here for seeing like how to render equation. You were here to see what happens if I put code. Let's see, friends, Fred, Michael, Gary. I don't know, I'm just trying to remember things. Here. For I name in enumerate friends. Notice that immediately put the tab for you because it knows that it's Python. It has assistance. This is important as well. For every language, they offer different facilities. Some language even offers autocomplete. So it's the same things that you are used to seeing in a full-blown IDE. You have autocomplete, you have assistance with the code. Some of them like even tell you where are the errors and things like that, debugging facilities. Print. This is actually a sample, I remember. I did it so many times that. Oh, you see, it has a problem. It's format, not print. I did that on purpose, of course. Another thing is that you are not subject just to the language that you are using. You can execute shell commands, for example, to list the content of your current directory. Just append with a bang at the beginning, and you will see it will evaluate that. There are options as well to execute other languages in the same notebook. For example, if you want to execute something written in Bash or write your own Bash script, you just pass Bash and write the Bash command over there. If, I don't know, directory is code, blah, 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 blah. Bash is made by the devil, so I'm not really good at it, as you can see. And one of the things that I mentioned as well is that you display information because it's actually pluggable. By default, we support things, or the people who run Jupyter support Matlag and Matplotlib and other rendering libraries. In this case, we just can copy-paste this. With Matplotlib, it will just... And you can see the chart done at the same time. I really like this ability because a few months ago, I decided to start learning compression, algorithms about compression. So it was really nice to see start writing my algorithms directly in the notebook, getting an image and see the compression algorithm, how it works. I change the image. You don't, instead of just waiting, press F5 in Visual Studio and see the results. This is one of the reasons that I really love it. You can see immediately what is happening over there. You don't have to wait for things to finish compiling or anything. There are other options that we will see over there, but it's in the next demo. So let's continue. Where's my mouse? Oh, here it is. Again, as you see, I mentioned Jupyter. Jupyter is just a split from the guys from IPython or Interactive Python. The idea was very simple. The idea is that the people from IPython are going to be dedicated just to the kernel of Python, that handle Python, while Jupyter is more about the whole set of the notebook application. That brought many, many advantages because currently, Jupyter is not just Python. It supports dozens of languages. Last time that I checked was over 100 languages. We are going to mention here just the beginnings of how to write your own your own language support or your own plugin for Jupyter this later because I'm a developer and I like that type of things. As I said, IPython is just the Python kernel for Jupyter. Jupyter support extensions and plugins is nice to extend. It's amazing. It's like there are extensions for doing a lot of things to show interactive charts, to show maps that just like pull the data from somewhere else and show other things, etc., etc. And recently, Jupyter Hub allows you to, if you have an office or you work in research or something like that, just install your Jupyter hub in the server, and you can have multiple users. They will have logins, they will get in, they will just collaborate between them, they can handle the permission of their notebooks, the execution permissions, they can create read-only notebooks for certain users, etc., etc., etc. Everything in a network. Just imagine that. This is really important because where I work, we have a data science department, and most of them are researchers. And one of the things that in the past they used to collaborate with Word documents. Most of them are ex-academics. So this speed of these Jupyter hubs just make everything so faster, and they love it because they just working their prototypes and can discuss that with the data engineers that are putting that into production and things like that. And they don't need to wait to write a paper or anything like that to make it happen. I'm really, really happy of that change in the workflow for them. And I want to introduce this more to developers so they start doing all the spikes and ideas as well in such a way that everybody can see what is happening. It's not a replace for GitHub or things like that. I will see that, in fact, GitHub has a special support for Jupyter notebooks as well. Jupyter is the tool for data analysis and research. As I was saying today, one of the things that is amazing is that there's no research conference or data science conference where they don't mention Jupyter because it's their tool. It's easy to use. You can share your information with other developers. It's very well documented. The documentation on Jupyter notebooks are extensive. And it's polyglot. It supports many different languages. So why this is not used by programmers, by developers? Well, the truth, I don't know. I want to believe that is that you guys didn't know about it. But I really like it because additionally to that, we are used to thinking in a different way because we used to think in things like composability, code needs to be self-documented. We want things that are extensible, so we can bend them to do whatever we want, and we want something that is completely open. So there's no problem that somebody's going to sue me later because I'm using their format. Well, Jupyter Notebook is all of that. It's extensible, as I said. It's self-documented because the documentation is together with what you are doing over there. It's not a comment. It's proper documentation. It's composable because you can have a notebook that has all your functions and another notebook that is where you use those functions and include it as modules. Link notebooks. And a good example is extension. I will mention this because in the next demo we will see it. But NV extensions are kind of not official extension, but officials that actually brings you new widgets and new extensions to do things that we didn't imagine with Jupyter Notebooks. And I will show you a few of those. Let's return to the console. Mm-hmm. To make everything easier, I have Docker image with the kernels that I need. We'll talk a little more about that in a second. Okay. This is an installation of Jupyter Notebook with two kernels, one in Python and another with Ruby. That is just to show you that it doesn't matter. You can have multiple languages. It's a little tricky to have two languages working in the same notebook. It was one of the features that they wanted to add. But the problem that they hit, and that they hit that wall very, very early, is that languages between languages there is no easy way to tell you what is the result of the previous operation. For example, Ruby is an expression-based language, and every expression that you put has a return type, while Python is not. So they hit that very, very early, and they just scratch it. But certain kernels interoperate between them. For example, especially Python and R, the R is a language. That sounds like a pirate language, but no, it's a language. R is is used a lot between data scientists and statisticians, and you can interchange data frames between R and Python. So if you do your analysis in R, you just can do the presentations in Python, or totally the opposite. Do the analysis in Python, crunch the numbers in Python because it's much better to crunch numbers than R, and then display everything in ggplot in R, because you can change data frames between those two languages. It's not every language that supports that feature, but it's possible. In this case, I don't know R, so I cannot show you that. And Python and Ruby, they don't interchange code. But I want to show you a few extensions. As I say, it's very, very simple extension. One of the extensions that I made was this. It's just to change the syntax highlighting. It was really easy to do in just a few minutes. So you can install. The interesting thing about the extensions that we have is that if you install NB extensions, install all this bunch of extensions that you can deactivate or activate. One of my favorites, if any of you are in education or anything like that, is exercise. Basically, exercise, what it does is that you can create a notebook with exercises and the answers of the exercise and put this in your Jupyter Hub or in GitHub or something like that for your students to download the notebook and do the exercise. Jupyter Notebook is now used in education a lot because it's easy. It's just your students can just experiment, and they have the questions and immediately just write the answer and see if the answer works. And with exercise, it's easy for you to just create those exercises for your students. Notice that there are two. It's two common. There are two. They support different Markdown types, like Python Markdown is another type where you can embed Python code in your Markdown itself without having to create a specific execution cell. Another thing with that extension is that you can, let's say that you are writing in Markdown and you want to show in that Markdown the results of one of the cells. You can just put in between square brackets the number of the cell, and it would put the result in line with the Markdown. Table of contents, things like that. Once you run a notebook, you will realize that even when you are not looking your notebook, you will see that there is something there saying running. There's even a tab named running. And this is because it's a multi-user system now. And what it does is that it spawns kernels somewhere else to communicate and execute your code. We will see a little how it works in the background. And what it does there is that it will just run until it dies. That usually happens with long running notebooks. So just be careful, and this is more like you have to start looking at if you are using that notebook or not, and once in a while shutting it down. Just imagine that it's a software that is waiting there to see if there are more input. You support clusters as well. As I was saying, one of the advantages of this, especially if you are doing very heavy computation, is that you can have machines running parallel Python on different kernels, and you just spawn the calculations to those machines, and you just get the result. So how all this magic works. That's when we are going to be a little developers now. How all this works. This is the boring part, probably. what is the short part as well. The way that they solve this, or they make this happen, is decoupling the execution from the presentation. So basically what you have is what is called the Python kernel, or the kernel itself, that do the execution of your code at the notebook at the front. That is just a client of that. Under that premise, you will realize that your notebook is just a client of your kernel. So you have just something in the middle that is forwarding the messages between the executor and you that are consuming those things. So that's the reason that we have different clients as well. We have a Qt client that uses the same infrastructure and things like that. I actually have seen even a client for Python notebooks in Atom. So you just write in Atom and it spawns messages to a Jupyter notebook kernel and gets the result evaluated. If you look at the documentation, how to do this, this is what they tell you. I'm still not understanding what is that about. Just didn't get it. And then I just realized that it's very simple. It's just the typical client and server communication. You have a client doing requests and getting response from a kernel. That is your server. So every time that you evaluate something, the client just says, hey, can you execute 1 plus 2? And the kernel just returns, yeah, the result is 13. As you can see, this is a pretty bad kernel because 1 plus 2 is not 13. I don't know what I was thinking. The only difference is that this is repeated in 5 different subsystems. So it's not just one server that do all the execution. You have the first, that is the shell. That is the most important, is who does the execution. It's the one that you say like, oh, can you tell me how much, what is the value of this? Oh yeah, sure, no problem, it's this. The other is the IO pop, is only for mutability. Every time that you mutate a value, for example, that you have a notebook that you already evaluated, and you change that cell, you need to notify every consumer of those notebooks, because remember that you can link notebooks together, that it changed, so they need to recalculate. And the others are standard in, that is just handles off the input-output between client and server. The control, that is just what tells you shut down, start, restart the kernel. And a heartbeat, just to know if that thing is alive. That's the reason, because we see the running. This is just, if you want to get into that, it's pretty simple. There are 2 types of kernels. The first is called the wrapping kernel, or wrapper kernel. And the second is the native kernel. We will touch first the native kernel, because I'm not going to explain this. It's very, very nerdy, but we can talk about that later, like outside, when we're having a beer or something like that. Native kernel is all those sockets that you saw, all those 5 things you have to implement from scratch using 0MQ. So you have to take care of the evaluation, you have to take care of the heartbeat, you have to take care of many other things. It's a lot of work, but it has a big advantage. You have the flexibility to do whatever you want, and you don't even need to implement or to use Python at all. In fact, the IO kernel, kernel that is used by OCaml language, you don't even have to install Python notebooks or Jupyter to use it, because you just copy all the JavaScript files that it needs and you put it together in the dependencies. As you can see, most of them are good examples of kernels that are implemented natively. For example, the JavaScript kernel is implemented, as far as I remember. There are 2. One is using the Node evaluation engine, and the other is using the MoseScript engine, the Mozilla JavaScript system. There is one that is not there, but I've been using lately. That is a kernel to learn Fortran. It's as well like part of that. Just feel free to take a look at the source code. It's just if you want to do something, but I don't advise to do full native kernel from the beginning, it's easy to just do a wrapper kernel. A wrapper kernel is just, you use Python, you just write a process, adding that you have to inherit from a class named kernel that it comes in that namespace. And the only method that you have to fulfill is to execute. Everything else is just if you want to do autocomplete option or hipster support, etc., etc. But the only method that you have to implement is to execute. Many kernels are wrap kernels. For example, the Redis kernel, that is a kernel so you can issue Redis commands and look at Redis clusters from your Jupyter notebook. And this is interesting. I mentioned the Redis kernel because this is where most of the conversation between developers happens. Is, oh, but you know what? I would really love to have, I was talking with one developer outside, and he says that he has its own login format system. So like, you can create one kernel, wrapper kernel for your format if you already like communicate somehow. And you can just like go in Python notebooks and just issue queries to see the results. You don't need to write a full screen or anything from scratch. Just use it. There's another subtype of kernel that is the REPL wrapper. This is more used for shells. For example, the Bash kernel and the PowerShell kernel are made in this way. Are they more advanced? Yeah, there is a PowerShell kernel, so you can just like play with PowerShell inside Jupyter. Almost finishing, but to run Jupyter now, if you want to start like playing with it, the easy way is just pip install Jupyter all. You need Python, and this will install the whole Jupyter chain set. Very easy, just take a few minutes. If you are using Windows, the easy way is using Anaconda because it includes Jupyter notebooks in the distribution. Anaconda is used by data scientists a lot because it includes as well a lot of data analysis packages like Panda, NumPy, SciPy, Matplotlib, etc. Another thing that I have to mention here, if you install in this way, that is my favorite. Once you install this, if you use things like R, JavaScript, or similar, you just pip install the R kernel, and it will install R and everything that you need. The same with the JavaScript kernel. Most of the kernels that we saw native that are provided by the Jupyter guys. Another option is Docker. There are multiple images of Jupyter notebooks in Docker. One of them that is the famous image is really big. It's 2.1 gigabytes, but includes a lot of kernels and includes as well all the libraries that you will need for analysis. And another option is Microsoft Azure notebooks. Those that have an Azure account, you don't even have to pay for this because the beta version just gives you the notebooks for free. They support, as far as I know, Python, R, F#, and yeah, I think those three. There was like some discussion about supporting C# as well. The C# kernel uses script.cs, but it's already free. You just go create an account and start playing with your notebooks over there. Once you have your notebooks, another option to share this with the rest of your colleagues or to share your beautiful notebooks with the world is using NBViewer. That is part of the Jupyter Notebook project. It's actually an open source project, so if you already have notebooks and you want to install in your machine for your company, go ahead, do it. And the idea here is that you can just point to a GitHub repository that have notebooks, and you see the notebook render and evaluate it. This is important because then GitHub is your repository for research or your repository for education. You just write your code, push to GitHub to a repo, and when people come to here, say like, oh no, I already published my findings. Just go, this is the repo. They point there and they see your your repository render. We will see in a second. And the other is that you don't need actually now MV Viewer, because since 6 months ago, GitHub supports Python notebooks, or Jupyter notebooks natively. So you don't need anything. It renders your notebooks. Let's show that here. Bless you. And you can say that support like hipster languages as well, like Julia. So you just point to a repository and it renders as nothing happened. Let's go GitHub, Jupyter, repository. Because I don't remember if I have any important. Yeah, they mentioned this. Yeah, this guy, he is studying analysis of whatever that is. But we just click in, but this is outside. Let's see here. This is inside GitHub itself. We just create the notebook, and the notebook is rendered. You don't need any external viewer or anything. Everything is rendered directly into GitHub. And I really like that. And another option is a new project. This started just a few months as well. It's called Interact. It's for those people that, for some reason, they don't like the interface, the web interface of Jupyter Notebook. This is more like a desktop application that supports Jupyter Notebooks. So you just connect through the protocol, and it's a desktop app. It's the same mechanism. If you want to do something more advanced, like, for example, get the information that you have in your Python notebook, the format IPython notebooks is completely open. In fact, for my personal blog, I have a static content generator. I use Pelican. And when I have to just write some code and things like that, instead of the previous workflow that I have, that was writing that code and then copy-pasting a Markdown file, now for cases like that, I write that blog post, the whole blog post, in a Jupyter notebook. And then as part of the publish process that I have a converter from the Python notebook to, not even Markdown, directly into HTML, and it will get all the styles and things like that for my blog. I heard that people are doing that as well to transform our Python notebooks into Word documents. I don't know why you will do that, but yeah, there is a possibility to do it. And it's completely open. You can read it, you can write it, go for it, go crazy with it. It's highly documented, so it's in the Jupyter Notebook documentation. Well, I hope that at least after this, you will have the curiosity to go and do pip install Jupyter, because that's what I want you to do. If you want to take anything from this session, is please go and play with Python notebooks or Jupyter notebooks. You are really missing something great. I wish I will tell you more nice words about it, but I think that you have to discover by yourself. Thank you very much. That was all. I will be outside just talking about more notebooks and stuff, or programming in Atari 2600 if you want to listen to me about that. Thank you.